So we're doing Transformations Unit 1 video by me.
So right now we're going to be focusing on linear equation. The linear equation is y equals mx plus b, which is going to look like this when you graph it. So first, we're going to say what each of them means. Y is y-intercept, m is slope, rise over run, x is equal to x, that one never changes, and b is the number on the y-axis. So if we were to do this with y equals 3x. 3 is the slope, which is m, rise over run, so 3 over 1. So when you graph it, it's going to look like this. You have your little graph, it's going to go up 3, over to the right 1. You have to do it down so it makes a straight line. It's going to go down 3, but this time it's going to go over to the left, because if we're going over to the right, just make a straight line down, it needs to be a linear line. So it's going to go down 3 to the left 1. Now, if you had a negative slope, it's still 3 over 1, but it's going to be negative. So this time it's going to flip. It's going to be up 3 to the left 1, down 3 to the right 1. Now, if you had something like this, y equals positive 3. It's going to go, since it's positive 4, positive means it moves to the left. Negative means it moves to the right. So if it's positive 4, it's going to move to the left 4. Now we have a positive slope of 3. So it's going to go up 3 over 1, down 3 over 1. Now we're going to focus on parabolas. Parabola equation is y equals x squared. You still have the mx plus b, but you have to have the x squared to make it a parabola, to make it have a curve. So if we're going to do transformations of vertical stretch and vertical shrink, we're going to look at the slope. So y equals 3x squared. The 3 is going to make it have a vertical stretch. Because in order to have a vertical stretch, you have to have n, or the number, greater than 1. So if you have a number greater than 1, it's going to be a vertical stretch. That means it's going to make it look narrower. So when you have that, you're going to go up 3, over to the right and left 1 to make it have a vertical stretch. Now if you're going to have a vertical shrink, the number has to be less than 1. So 1 over 3 is less than 1. So let's make it have a vertical stretch, makes it look flatter, makes it look like a pancake. So you're going to go, instead of going up 3 over 1, you're going to go up 1 over 3. Now we're going to look at reflection. And if you have a reflection, that means it's going to go flip over the x-axis. So in order to have a reflection, there has to be a negative in front of the slope. If there's a negative in front of the slope, that means it's going to reflect. So this is still going to be a vertical stretch because it's greater than 1. So it's going to be a reflection plus a vertical stretch. So you're going to reflect it, and it's going to go down 3, over to the right and left 1. Now if we look here, just like we had over here, x plus 4, plus is left, negative is right. Now we have y equals 3, positive 3, it's greater than 1, going to be a vertical stretch. X minus 2 squared, so it's going to be parabola. Minus 2 makes it go over to the right, 2, up 3, over to the right and left 1. We're going to look at translating up and translating down. To translate up, you have to add a number after the x plus whatever the number is. So we're going to keep with this equation. We're going to have y equals 3, positive 3 is still going to be a vertical stretch. X minus 2, so moving to the right 2, but now squared. But now we're going to add plus 1. That's going to make it translate up. So if you do each step, you still move it to the right 2. Now you're going to translate it up 1, and you're still going to do positive slope of up 3 over 1, so it's a vertical stretch. Now if you want to translate it down, all you have to do is make this a negative. So you're still going to do each step, it's going to still go over 2, it's going to go down 1, and still going to go up 3, over to the right and left. Here are the graphs for each parent function. So constant f of x, well now y is f of x, so you are able to do more steps, is equal to 1. Quadratic f of x is equal to x squared. We've already done that, where it makes a U shape. The quadratic goes across the 1. Square root f of x is equal to the square root of x, and it starts at 0, and it goes up, hits 1 on 1, 1. The slope 1, 1, and it keeps traveling up. Cubed, f of x is equal to x cubed, and it makes this like weird snake line, and it crosses through 0, 0. Linear, we've done f of x equals x, makes a straight linear line. Absolute value, f of x is equal to the absolute value of x, and instead of being like the quadratic, it makes a U shape, it makes a V shape. Exponential, f of x equals bx. It starts at 1, and it goes and it grows exponentially. Reciprocal, f of x is equal to 1 over x, and it makes these two lines that never hit the axes. We're going to replace y with f of x. So when you do that, let's say f of x is 16. So we know f of x is 16. Now we're going to have g of x equals f of x plus 5. So f of x is 16. So f times 16 plus 5. 16 plus 5 is 21. G of x equals 21. Now let's add another equation. H of x plus gx plus h of x equals gx plus 3. G times 21 plus 3. So 21 plus 3 equals 24. So h of x is equal to 24. Now let's add another one. I of x equals f of x plus g. So I of x equals f of x plus gx plus hs x. So we have all of those answers. F of x, we have f of x 16. G of x is 21. H of x is 24. So now we're just adding them all. So I of x equals 16. Now let's say we have a completely, now we wanted to figure out I of x equals x plus 5x plus x plus 5 plus 3. We're doing common factors. I of x equals 3x plus 13. Now, we have f of x. F of x will never change, like, letter. You always start with f of x, but then letters before x don't really matter. You can have b of x, q of x, c of x. It doesn't matter. You can have f of x of x. I mean, it doesn't really matter as long as they're not. You can tell the difference between each equation. Expectancy. So we have the well-being here, 0, 2, 4, 6, 8, 10, and then we have years of age, 20 to 100. And those little purple dots are the average. So as you can see, the older you get, the happier people get. So the way to read the scatter plot and see if it's actually a best fit line is the closer they are to the line and the more spread out they are on the line, the better best fit line it is. So let's say if I had a different well-being versus something else and it was green. And if it was more closer to the line and spread out like this, it was closer to the line, more spread out on the line, that would be a better best fit line. So let's move on. If we have life expectancy versus well-being, we want to know if it increases or decreases. You can simply tell by which way the line is going. So if the line's going this way, and it's going from the 0 or the 20 or the 40 or the 60 or the 80 or the 100 even, and it's going up this way, that means it's an increase. Now, if the line was going the opposite way and it started from here and moved downwards this way, then that would be a decrease in life expectancy versus well-being, and that would be a decrease if it went down this way. So let's erase that one. And this is some of these little dots right there. Now we're gonna go over an equation doing with this equation. That's what I have. So the question is asking, what is the exact level of happiness of someone living to the age of 65? The answer is 4.8951. So if you were to live to the age of 60, now let's say so right here, and you went all the way up and you crossed it, it would be at 4.8951. The way you find that is you use this equation. So down here, if you use that equation right here, you want to find age of 65. So you take 0.0895x. But you can replace x with 65 because that's what you're trying to find out. So you get the answer of 5.8175 minus this number, 9.9224. You're going to get the answer of 4.8951. And that is the exact level of happiness of someone living at the age of 65. Now we're going to be focusing on homecoming, the word problem. So in the word problem, we know all of this. We know the cost of tickets for students with ASB is $5. Students without ASB is $7. Guests is $10. The amount of tickets sold that entire night were 282, and the profit was 2,318. Now we do know is there were 57 more guest tickets sold than non-ASB. So first we're going to come up with equations. The first equation is total of tickets sold. The first equation, we're going to use the Roman numerals to number them off, is x plus y plus z equals 282, because that's each ticket and the amount of tickets sold. Then we're going to do, we had 57 more guest tickets sold than non-ASB, so the second equation is y plus 57 equals z. Z is guests, and we know we have y, so 57 plus students without ASB, which is y, and that is equal to z. Now we're going to do the third equation, which is going to be revenue. We're going to have $5 plus $7 plus $10 equals the entire revenue of the night, which is 2,318. So now we have all of that. Our first step is substitution. So when we do substitution, we're going to take two formulas. So we're going to take 1 and 2. And the reason why we're taking 1 and 2 is because we are able to substitute this equation, the second equation, into the first equation. The reason is, it's because we know what x is, so we can substitute that for the x in the first equation. So when you do that, it's going to look like this. X plus y plus 57 equals 282. And once you simplify all that, it's x plus y, 57 minus 57, and then 282 minus 57 equals 225. So x plus 2y equals 225. And we ended with x and y. And this is going to be important. I'll show you why in elimination part 2. We're going to take two new equations. We can't use 1 and 2 again, so we're going to use 1 and 3. So we're going to do x plus y plus z equals 282. And 5x plus 7y plus 10z equals 2,318. The reason we're adding the x, y, and z, and we don't have it up here, is because we need to know what each number stands for. So, like in part 1, we ended with x and y. In part 2, we also have to end in x and y. So, we have to get rid of z. So, the way we get rid of z is we're going to multiply this entire top equation by negative 10. And once you do that, it's going to be negative 10x minus 10y minus 10z equals 2,820. You're going to keep this equation the same. 5x plus 7y plus 10z equals 2,318. Once you add, subtract, do the common factors all the way down, you're going to get 5x plus 3y. The 10's cancel out, equals negative 502. I have all equations here, part 1 and part 2. So in order to find y, alright, so now we're finding y. In order to find y, we have to use part 1 and part 2, these equations. So we have x plus 2y equals 225, negative 5x minus 3y equals negative 502. We have to get rid of x in order to get y by itself, so you can multiply the entire thing by 5. Once you do that, it's going to look like this. 5x plus 10y equals 1,125, and then part 2 equation. So the 5's are going to cancel each other out. Those are gone. So you're left with what's left. And then so once you simplify, it's going to be 7y equals 623. Divide the entire thing by 7 to get y by itself, and y equals 89. So now we're going to do x. In order to find x, all we have to use is the equation from part 1. X plus 2y equals 225. The reason we only have to use 1 is because we know what y is, so we're able to cancel it out. We know y is 89. So x plus 2y equals 225. X plus 2 times 89 equals 225. So once you multiply 89 times 2, it's 178. You subtract 178 by both sides of the equal sign, and x is equal to 47. Now to find z, you're going to use equation 1 that we came up with. Not part 1 or part 2, equation 1. The reason we're using equation 1 is because it has all the variables and the amount of tickets sold. We know what x and y is, so we can easily get rid of z. Find z by itself. So x is 47 plus y is 89 plus z equals 282. So 136 plus z equals 282. Subtract 136 on both sides, and z is equal to 146. Now that you have x, y, and z figured out, we have to find out how much profit all of them came in. All the profit came in. So we have y is equal to 89. We know y is students without ASB. So each ticket sold for $7. So you take 89 times 7 is 623. X is with ASB. So 147 times 5, because that's how much ASB tickets are sold for, is 235. And then Z is the guest. There's 146 tickets sold. And we know they're sold for $10 each, is $1,460. So your answers should look like this. And those are your answers. Number of ASB tickets sold, number of non-ASB, number of guests, amount ASB made, amount non-ASB made, and the amount guests made. And that is how you solve for the homecoming question. Hi, Mr. Suhu. I know my video is like really, really late, but I had fun making it once I figured out how I was gonna make it. I made it, and then I realized that I did it really bad, and it was like 20 minutes long, so I was like, oh, I should probably redo it. So this one's shorter, better. I would show my face right now, but I have massive bad head and makeup all under my eyes. So I'm just gonna say hi, Mr. Suhu, and I had a blast making the video.